Sensory neurons are the nerve cells responsible for converting a stimulus into an electrical impulse. Sensory neurons take the stimulus and convert the stimulus into an electrical impulse, which is then sent to the interneuron, which sends that electrical impulse to the brain as well as to the motor neuron. Upon being sent to the motor neuron, the interneuron decides whether a reaction should be made to move away from the stimulus. An example of this is when you burn yourself when using a hot pan. The hot pan is the stimulus. The sensory neuron then sends an electrical impulse to the interneuron. The interneuron then sends the message two ways, to the brain and to the motor neuron. The motor neuron receives this message and instantly reacts, resulting in a reaction. Sometimes this is why we have a delayed reaction to pain. Without the sensory neurons, we wouldn't have the five senses that are key to living every day.
Thermoreceptors are nerve cells that detect the temperature around your body and outside. They decide if you're too hot or too cold, whether you need to put a jumper on or take one off. The number of thermoreceptors will determine how sensitive your skin is to temperature changes. That means that if you get hot or cold easily, you have sensitive skin, which results in insensitive thermoreceptors, and if you're always just right, then you don't have sensitive thermoreceptors on your skin.
Thermoreceptors are the sensory neurons that are responsible for detecting warmth or coolness. Thermoreceptors do this in two ways, with two different types of sensors. One for detecting the heat, which is a temperature over the regular body temperature, and one for detecting the coolness, which is the temperature below the regular body temperature. Although it is unknown on how the actual thermoreceptors work, we know that it works on the same principle of any other sensory neurons. Once the message is received from the sensor, it is sent through the sensory neuron that detects something dangerous or abnormal. It sends this message through electrical impulses to the interneuron, which relays the message to the motor neuron, but at the same time sending the message through the central nervous system to the brain. The motor neuron causes the muscle or organism to react and either remove or change their action.
Thermoreceptors are all over your body, but cold receptors are most commonly found in bigger amounts together than heat receptors. The highest concentration of thermoreceptors are on your face and ears. This is why your face and ears are the first parts of your body to suddenly feel the change in temperature. Heat receptors are located closer to the surface of your skin, and your cool receptors are located further below your skin. Hence why you are more sensitive to the heat than the cold. Thermoreceptors give crucial information to the brain, telling it whether it is cold or warm around you. It is important, as if you didn't get this information, you would have no idea whether it is warm or cold, whether you need that jacket on or not. This can be crucial to our survival, as determining how hot or cold we are can mean the difference between life and death. At either end, we could be suffering from heat stroke or hypothermia, and without thermoreceptors, we wouldn't be able to determine this, and in the worst case, this would lead to death.